Okay, Assalamualaikum and hello everyone. So, welcome to our first chapter for semester 2, SK025. So, it is reaction kinetics and our first subtopic will be 1.1 reaction rate. So, let's look at our learning objectives for today. We will need to know a few new terms which are reaction rate, differential rate equation. So, you need to know differential rate equation so that you can determine your reaction rate. Then you need to know what is rate law, order of reaction, and half-life. Okay. Then you need to know how to write down rate law with respect to your order of reaction. Okay. Once you know what is rate law, you can write your integrated rate equation. Okay. For first and second order specifically, you don't need to know for third order for integrated rate law. Okay. So sometimes you are already given the rate law, so you know the order of reaction for each of your reactants. Okay, but if you are not given that, okay, you need to use these three methods, which are initial rate method, half-life method, and linear graph method. Okay, finally you need to know how to do calculations using your integrated rate equations atau integrated rate law. Okay, so first things first, reaction kinetics. Why do we learn it and what is it about? So actually it is the study of rates of your chemical reactions. So basically how fast your reaction goes. Okay, and you learn about the factors that will affect these rates. Okay, so in chemistry, sometimes in industries, okay, dalam kilang you want to make chemicals, right, and in large amounts. So like you need to find out what is the best temperature, what is the best pressure, and stuff like that, so that you do not waste energy or chemicals, and also for safety measures. Okay, so that's why you learn reaction kinetics. So the first term that you need to know is reaction rate atau rate of reaction. It is the changes in concentration of reactants or product over time. Okay, so let's say this is our general chemical equation, general reaction, where A is your reactant and B is your product. So as the reaction goes, your concentration of A will decrease while the concentration of B will increase. So when you write the rate punya equation, you can see that the concentration of A, okay, will decrease in time. Okay, that is denoted by the negative sign. So here you write rate equals to negative change in concentration of A over time. So basically the concentration of A decreases with time. Okay, while your product increases, so you will have a positive at the front. Alright. Okay, so what is the unit for rate? Okay, you already know the unit for concentration. It will be mole per liter or mole per dm cube, or can be written as molar. Okay, so the unit of rate will be concentration over time. Okay, so it can be this, mole per liter per second, mole per dm cube per second, or molar per second. Alright, so the unit of time can be either any of these. Okay, depends lah, dalam soalan tu dia tulis in which unit, so you just follow. Alright, so your unit for rate can also be this, in this way. Okay, so in this slide we will learn how to read the graph of H2O2 concentration against time. So right here we have the curve, okay, of the concentration against time. So basically you can see that the concentration is decreasing with time. Alright, so here we can see our purple slope here. Okay, this one gives the average rate of your reaction. So you can find the rate of your reaction using gradient dy over dx. Okay, just using this slope, meaning you carilah dia punya value here. Okay, and if you want to find the instantaneous rate, okay, instantaneous maksudnya at a specific time, such as time 300 seconds, right here, you will need to draw a tangent at straight tangent at this time. Okay, and then find the rate using the gradient. Okay, kalau initial rate pula, initial rate maksudnya time equals to 0. Okay, masa awal-awal awak punya experiment. So you will also need to draw a tangent at t equals to 0. Okay, and just extend it. Then you can find the gradient using the slope. Okay. Okay, next term you need to know is differential rate equation. So, differential rate equation, it shows the relationship between the rate of disappearance of your reactants and the rate of formation of your products. Right? So, consider this general chemical equation here. Okay. The way to write your differential rate equation is like this. Okay. So how? You will look at the stoichiometric coefficients at your balanced chemical equation. Alright, so you must write rate equals to, okay, then look at your reactant. So your reactant A, you will write negative 1 over A, its stoichiometric coefficient. D, concentration of A, maksudnya change of concentration of A over time. Okay, equals to, then do the same for B, right? And then you have this negative because they are reactants and the concentration of your reactants will deplete, berkurangan, that's why you have negative. And then for your products, you will have to put positive. Alright? Okay. So ingat, differential rate equations, you will look at balanced chemical equations and then look at the stoichiometric coefficients. Okay, it is not the same as rate law. Okay, lain. Rate law is different. You need to have K. You need your rate constant. Okay, so our first example, you need to write the rate expression ataupun differential rate equations. Okay, it is not rate law, not rate equation, ingat. Okay, so look at your balanced chemical equation. So let's try doing it. So look at your reactant first. So your reactant will have negative. So since it has 2 here, it will be 1 over 2. D, concentration of H2O2 over dt. Okay, equals to your product will be plus 1 over 2 d H2O over dt equals to plus d oxygen, okay, over dt. Okay, so since this one here you don't have anything, so basically it is 1, so you don't need to write any fraction lah kat depan ni. Okay, right, ini you try doing it yourself. Okay, right, so you can also use your differential rate equation. Okay, ini saya dah tulis daripada this balanced chemical equation to find the rate of formation or rate of disappearance of your reactants or products. Alright, so in this question here, it says if sulfur dioxide SO2 is being formed at a rate 0.30 mole per liter per second, that means that this is your rate of formation. Maksudnya D, ni plus D over dt for SO2. Okay, what are the rate of disappearance of hydrogen sulfide, H2S and oxygen? So that means you need to find the rate of disappearance, maksudnya negative D over dt for H to S and negative D over dt for oxygen. Okay, so first write down your differential rate equation, alright, and then identify the information given. So you are given the rate of formation of SO2. Okay, and then look at your differential rate equation. Mana information yang you already have? Which informations you already have? So you want to find this one first, right? You want to find the rate of disappearance of H to S, and you are given the rate of formation of SO2. So you're going to take these two only. Okay, so write down negative 1 over 2 d H to S over dt equals to plus 1 over 2 d SO2 over dt. Okay, and then from there, masukkan what you already know. Okay, oopsie, equals to 1 over 2 times 0.30. Okay, and then you want to find this, right? So that means you need to move this 2 to your right. Alright, okay, since we don't have any space, I'm gonna make this smaller. Okay, and then you're going to write negative d over dt H to S, okay, equals to, so times 2 kat sebelah, maksudnya you tinggal 0.30 lah molar per second. Betul tak? Kan? Okay, so this is the answer given. So you can try for rate of disappearance of oxygen. Okay, and you should get this answer. Okay, so make sure lah kat sini ada negative because you want to find the rate of disappearance for H to S. Okay, this one do it yourself. Next term we need to know is rate law atau rate equation. Okay, so they can interchange between those two terms. So this is an equation that relates the rate of reaction to your rate constant K. Okay, so rate constant K, it tells how fast a reaction proceeds at a given temperature. Okay, and the concentrations of the reactants raised to some powers. So what are these powers? These powers are basically your order of reaction. Okay, so let's look at this general reaction. Okay, so the rate law for that chemical equation will be as follows. Okay, so if you look here, you will write rate equals to, you must have K, your rate constant, and then concentration of your reactant A to the power of M. Okay, so M is the order of reaction with respect to your substance A, and concentration of B to the power of N. So N is the order of reaction with respect to substance B. Okay, so K is your rate constant, and to find the overall order of reaction, you will just add M with N. Okay, so let's say kalau M equals to 1 and N equals to 2, then the overall order of your reaction will be 1 plus 2. Okay, macam tu. If you notice, okay, for rate law or rate equation, it is not like differential rate equation. Okay, not like that because you, okay, obviously the way you write here is not the same. Okay, you have K, and M and N does not equal the stoichiometry coefficient small letter A and small letter B. Okay, so note here, okay, important, order of reaction is not your stoichiometry coefficient. Okay, how do you determine your order of reaction? We will look at the next slide. Okay, Your order of reaction, it shows how the rate is affected by the reactant concentration. Let's say kalau awak tinggikan, if you double the concentration of F2, what will happen to the rate? Okay, if you triple the concentration of F2, what will happen to the rate? Okay, how much will it increase by? Okay, so here I want to emphasize, okay, on the stoichiometric coefficient. If you look here, stoichiometric coefficient, it is not the same, okay, as your order of reaction. So this is the order of reaction, okay. You can see that for F2 you have 1. So kat sini 1, but at ClO2 you have 1 as well for the order of reaction with respect to ClO2. So, but if you look at your chemical equation, okay, your balanced chemical equation, your stoichiometric coefficient is 2. So, maksudnya 2 ni, dia tak ada kena-mengena, okay, for stoichiometry pula, for order of reaction, okay. Order of reaction is not the same as your stoichiometry, okay. So, your order of reaction, it can be 0, 1, 2, 3, half, 3/4, and so on. Alright? It can be those values. So, the reaction orders cannot be predicted from stoichiometry. Like I said, okay, it must be determined experimentally. So, maksudnya, you will be using your data lah. Okay, concentration data, your rate punya data given to find your order of reaction. Okay. Next. Okay. So, we can also determine the overall reaction order from the unit of rate constant, your K. Okay. So, look at this table here. Okay, it says if the overall reaction order is 0, then the units of K, where your time is in seconds, will be mole per liter per second atau molar per second. How is that so? How do we get this when our reaction order is 0? Okay, so the way for you to know your overall order of reaction from unit rate constant is for you to write your rate law. So in this case, for 0 order, okay, your rate law will look like this. Okay, so rate equals to K, your rate constant, concentration of A, okay, your reactant, to the power of 0. Okay, ni maksudnya 0 order. Okay, so from there, okay, the unit of rate, this one, is fixed. It will always be molar per second. So, dari sini, awak tulislah molar per second equals to K. Okay, you want to find the unit of your K. Okay, so A naught to the power of 0, okay, anything to the power of 0 will be what? Will be equal to 1. So, that means the unit for K will be just molar per second. Okay, so you can try out for other reaction orders. Okay, macam mana boleh dapat per second, and for second order, macam mana boleh dapat per molar per second. Okay, try out this example here. Okay, alright, so let's do this example, okay, to determine the order of reaction from rate law. So you are given this chemical equation and you are already given the rate law. So when you are given the rate law, okay, you can directly know the order of reaction with respect to your reactant H2SeO3, this reactant I minus, and this reactant H plus. So you can know the order for each of these reactants lah. So for the first question, they ask what is the order of reaction with respect to each reactant. So these are your reactants, okay? So you're going to look at your rate law, not your chemical equation, okay? So for H2SeO3, it will be apa ni? Kosong ke satu? It will be 1, okay? For I minus, it will be 3. For H plus, it will be 2, okay? Okay, so simple je untuk tahu the order of reaction when you are already given the rate law. Alright? Okay. B, what is the overall order of the reaction? Okay, kalau dia cakap overall order, maksudnya you will add up lah all the reaction order for each of your reactants. So 1 campur 3 campur 2, maksudnya you will get 6, right? You will get 6. So the overall order of the reaction will be 6. Okay. What are the units of rate constant K? So for the unit, how are we going to find it? This one I will show you again. So rate, we know that the unit will be fixed. It will be molar per second, right? So you want to find the unit of rate constant K. So write down K. Okay. So for your concentration, it will be molar, right? Okay, this will be molar. Okay. So this one will be to the order is 1, so this will be 1. And then you have I minus, it will be molar as well, but you have 3. Okay, for the order. And then H plus, it will be molar. Okay, because concentration kan to the power of 2. Okay, so from here, you just do maths lah. So to find K, okay, campur ini 1 plus 3 plus 2 dapat berapa? 6. M to the power of 6. And then, oopsie, I don't know maths. Okay, so M as negative 1 divided by M to the power of 5, right? So you do your maths and you should get negative, sorry, ini 6 negative 5 per second. Okay, so macam tu.